What's up, Hive? I got a very overdue video that I got to make for you. A lot of my actual vlogs, or even my TikTok sometimes, when I'm looking at a star, you'll see me reference that the star is changing colors or the star is twinkling. But I never really gave an in-depth video on why that actually happens. Hear not, hear thee. I am here. Stars are sources of light, right? So when you have that source of light, it's beaming in a light wave, in the form of a light wave, and it's going towards the earth, right? Now the earth has its atmosphere, and the atmosphere has different layers, and these different layers, they have different densities of air and of just general stuff that's inside it. So what you learn in physics is something called Snell's law. When light goes through a different medium, it changes direction ever so slightly. The angle will change. And so these different density layers cause different mediums. And so the air, the light wave, is changing based off the air. So it's bouncing back and forth and back and forth and back and forth. Another thing is, that's if it was just static. The atmosphere isn't static, right? The air isn't just a solid, it's actually moving. So with that air moving as well, it's causing it to change directions and back and forth and back and forth. And that's what's causing it to shift ever so slightly, where we think that the star is either moving or the colors itself, because the colors have different frequencies, right? And so those colors are bouncing off and going separate ways. So we see less of one color and more of another color changing over time. We call this process scintillation. That's like the scientific term of a twinkling star. Now, given my explanation, you may be wondering, why don't planets twinkle? It's very important. Planets are planets, right, in the solar system. They are way closer than even the nearest star. The nearest star is 4.25 light years away. And in simple terms, we're gonna make sure it's the same units, right? It's 40 trillion kilometers. Whereas Pluto is 4.28 billion kilometers. Now, a billion is a lot, but a billion is nothing to a trillion. So you see the difference, right? So Pluto is very far, and the stars are way farther. So what is that doing? What's the science behind this? What am I telling you this for? Okay, so this is why I love physics. I'm a physics major. We love to simplify stuff. When things are so much farther away, they become a point particle, right? So the light coming from stars are points. It's one ray. We describe them as one ray because it's so far apart that, like, even though a star is super big, we're looking at it so far that light is so small, it's only 1 point. Cool. Planets, however, are close enough where they are not a point, they're a disk. That's why when you look at you can see them through a telescope and you can actually see the whole planet, right? Okay, you are not gonna be able to see a star, the whole star, like with the close-up and details of the surface. It's gonna always look like a point. But the planet you can actually make out. The planet is gonna look like a disk. So with that larger surface area, even though there is some oscillation, given the ionosphere, they're gonna cancel out because there's a lot more light that you're able to see. And so even though it's like the whole shape is moving together instead of just one ray changing color, if that makes sense. So their apparent sizes are usually larger than the pockets of air that would distort their light. So the diffractions cancel out, and that's why we don't see that scintillation, scintillation with the planets. But for the stars, it's different. Now, hold your horses. That's not to say that stars don't actually change colors. Some stars do and can change their brightness, but that's over a long period of time. It's not going to be on that fast blur that you kind of see in some of my videos. It's going to happen over days, months, years, like a very long time for it to actually happen. And almost long enough where you can almost barely notice. You have to look between, like, okay, let me look at this 30 years ago and then let me look at this star now. And then you'll kind of see that difference in the magnitude. But other than that, I hope you enjoyed the video. Make sure to leave a like, make sure to subscribe if you haven't. If you didn't enjoy the video, Make sure to leave a like, make sure to subscribe. You know what we do over here. We're going to explain some more science facts. I got some other videos I'm cooking up for y'all. Make sure if you didn't already, go ahead and check out the vlog that I did when I was at the car show. We saw some really cool cars, got to meet some really cool people, and I kind of tell you about the cars that I was able to talk to people about. But it was overall a fun experience. I just want to share that with y'all. But I'm going to see y'all later. Ron to be out.